Hello students, welcome back to my channel. Today, as you can see, we are going to discuss about class 12's inverse trigonometric functions. This particular topic is very important because inverse trigonometric functions play an important role in calculus, and the concept of inverse trigonometric functions is also used in further studies like engineering and any other research in science. So before we start inverse trigonometric functions, the topics that is given in class 12 syllabus, I just want to say one thing, that inverse of a function that is like inverse, the function is suppose f, so inverse of a function will be denoted as f to the power minus 1, that is it will be read as f inverse. Okay, this exists if f is 1 and onto both together. We can say f is surjective and injective. That means we can say f is bijective. So only for bijective functions or bijective mapping we will have f inverse. That means if f is either not 1 or not onto, or f is not both, then we can say that f inverse will not exist. So for existence of f inverse, you need to get a function which is bijective. Now let us go to its basic concepts. Okay, you all know there are 6 trigonometric functions which can be defined as, means its domain and range you can say. So sine r means real number set, so its domain is r and the range is -1, 1. Cos r, range is -1, 1. Then tan r, actually it's not only r, it's r minus x such that x equals to 2n plus 1 into pi by 2, where n belongs to z. Z means integer sets, tends to r. Why this to be subtracted from the domain? Because you all know that for tans 90 degrees multiple, all 90 degrees multiple, tan will have undefined value. That's why we have to subtract all those points from the domain. Okay, coming to cot, similarly for cot also some of the points to be deleted. What I am writing over here, x equals to n pi tends to capital R. Then sec, r minus sec and tan, these two's domain will be same. Domain will be same only, not the range. Domain will be same. Range of sec is r minus -1, 1. Then cosec, range of domain of cot and cosec will be same. This will be r minus -1, 1. Range of sec and cosec will be same. Now let us take sine function only. So what is its domain? Its domain is r and its range is -1, 1. Now suppose if we restrict sine's domain to the interval, closed interval minus pi by 2, plus pi by 2, then you can see that suppose sine's domain we are restricting like this, its range again will be going to this, because you all know that sine function make a loop. Okay, when we draw its graph, it will make a loop like this. Okay, though the graphical representation is now deleted from the syllabus, but just to know it. So from this to this, it's 0 to pi, and this portion is pi by 2. Similarly, this side also, this is minus pi by 2. So you can take from minus pi by 2 to pi by 2. This value means this curvature, this curve. Okay, so this not curvature, that's a different term, sorry. So this curve, you can see this curves, every point is actually a point between this -1, 1 interval, right? Because this is -1 and this is 1. This side is -1 and this side is 1. Okay, so it's every point is, each and every point of this domain is connected to the points of the interval -1, 1. So if we means what I can see, if we study in detail, then we will be getting that in this domain and with this range, we will be getting that sine is 1, 1 and onto both with this range and domain. Similarly, sine is 1, 1 and onto with some different intervals also, like -3 pi by 2, minus pi by 2, and then pi by 2, 3 pi by 2, like this, and etc. Means all those intervals like this, for these intervals sine will be 1, 1 and onto. Okay, it means in these intervals we can define inverse of sine function. Why? Because it is 1, 1 and onto. That means sine inverse exists, and then sine inverse domain will be -1, 1, and the range can be anything, any interval, either this or this or this, any interval. I am taking this one, minus pi by 2, pi by 2. Now, sine inverse will have many value branches. This one, this one, this one, all are the branches. Okay, these are called the value branches. Now, only this branch is called principal value branch. This is called principal value branch for the function sine inverse. Okay, now from the definition we have got one thing, that sine of sine inverse x. How we will be writing it? Sine inverse x going from -1 to minus pi by 2, pi by 2. That means sine will go from this point to this. That means again x. It's coming back. So it will be x. Similarly, sine inverse of sine x will be x. For this, x belongs to minus 1 comma 1, and for this x belongs to minus pi by 2 comma pi by 2. Okay. So we can say one thing, that we can say that if y equals to sine inverse x, then we can say that sine of y equals to x. Sine y equals to x. Now, I can construct a table for principal value branches for all 6 trigonometric functions. Inverse. Okay, inverse trigonometric functions. So, sine inverse, properly I am writing here, and its principal value branch is minus pi by 2 comma pi by 2. Cos inverse minus 1 comma 1 0 comma pi, closed interval. Then tan inverse capital R, means real number set to open interval minus pi by 2 comma plus pi by 2. Then cot inverse 0 comma pi but open. Sec inverse this is the domain and this is the range. Cosec inverse R minus 1 comma 1 closed interval minus pi by 2 comma plus pi by 2 minus the point 0, means the singleton set 0. Okay, so this is very important topic, means the main here, principal value branches for all 6 inverse trigonometric functions. Now, one very important thing to be noted, that is, suppose I am writing sine inverse x. Sine inverse x, it is not equals to sine x to the power inverse to the power minus 1. So it is not equals to, okay, because sine of x to the power minus 1 means it's 1 by sine x. Rather, sine inverse x means its inverse function. So sine inverse, the whole term is a function. Okay, it can't be broken into 1 by sine or something. It's not a product, not a multiplicative inverse. So it's another function. It's not multiplicative inverse. It's another individual function. Okay, now the values. Okay, you have got all principal value branches for all 6 inverse trigonometric functions. Now the value of an inverse trigonometric function which lies in the range of principal value branch. That means the value of this, the value of whatever this means, it lies in the principal value branch. They are called principal value of that function. Okay, they are called principal value of that function. Okay, now with that note, we can do some examples. So I'm going to exercise 2.1. Okay, let me just check your book once. Question number 7. The question is, find the principal value for sec inverse 2 by root 3. So we will first take, let whatever given, that is equals to y, and that means sec y equals to 2 by root 3. We will find out its value normally. So it is actually sec of pi by 6, right? Now look, we need to now look at principal value branch of sec inverse. What is the principal value branch? It's 0 comma pi minus singleton set pi by 2. So we will write that as the range of the principal value branch, or we can just write down as the principal value branch of sec inverse is 0 comma pi minus singleton set pi by 2, and we have got sec pi by 6 is equals to 2 by root 3. That means we can say, therefore, principal value of sec inverse 2 by root 3 is equals to pi by 6. Okay. Anyhow, we have to find out this. This angle must be lying in this range. Let's do another question. Question number 10. It is given as cosec inverse minus root 2. Again, we will take this as y. It means cosec y is equals to minus root 2 equals to minus cosec pi by 4. Minus cosec pi by 4, we can write it as cosec of minus pi by 4. Now look, why I have written it? Because as principal value branch of cosec inverse is minus pi by 2 comma pi by 2 minus singleton set 0, and cosec minus pi by 4 is equals to minus root 2. You can see this minus pi by 4 lies within this range. Okay, that means, therefore, principal value is minus pi by 4, and this is the answer. Okay. So students, this is all about today's sessions. I hope you all have understood it. I'm just showing it to you once so that you can get the idea of whatever the portions we have completed today. Okay. So these are the portions that we have completed, and related to that, exercise 2.1's all questions can be done very easily. Next part of this chapter is now deleted from your syllabus, and the graphical representation of all inverse trigonometric functions also deleted from the syllabus. so I'm not going into that topic now. Okay, so this is the session, and we will meet in the next session with any other topic. Till then, have a good day.